Hello, BYW students, it's Mr. Sullivan. Today we're going to be looking at lesson 8-2, finding the axis of symmetry and the vertex algebraically. So this is actually a 2-for-1 lesson. Your Delta Math assignment will ask you one question on finding the axis of symmetry and then one question on finding the vertex. So only 2 questions, but a 6-point assignment. So today's learning target is I can determine the vertex of a parabola by applying the axis of symmetry formula. Remember, the standard form of a quadratic equation is y equals ax squared plus bx plus c, where a, b, and c are just numbers. To find your axis of symmetry, use the following rule. X equals negative b over 2a. And this is a rule you have to memorize. So you're probably wondering, Mister, how do I do this? So, steps for finding the vertex of a parabola. Here's our first example we're going to do together. Determine the vertex of the quadratic function y equals x squared minus 4x minus 5. Step 1 says identify your a and your b values. So the first thing I'm going to do is whenever I just have a good old x or an x squared, I'm going to put a 1 in front. That way I know I actually have a 1x squared. So let me show you what I'm going to do. So I need to identify my a and my b values. We just said up here that quadratics are written in this form. So I have y equals ax squared plus bx plus c. And I said I want to identify our a and our b values. So if you look, the number attached to my x squared is my a, and in this case, the number attached to my x squared is a 1. So I can say a equals 1, and now the b value is attached to my x, and the number attached to my x is a negative 4. So I can say b equals negative 4. Perfect. Step 2 says substitute into the axis of symmetry formula, and here's our formula, x equals negative b divided by 2a. So the first thing I do is I always rewrite it. So x equals negative b over 2a. X equals, and we just said that b was negative 4. So I have negative 4 over 2 times my a value of 1. What's the negative of a negative 4? It's a positive 4. So this becomes x equals 4. What's 2 times 1? 2. So what's 4 divided by 2? 2. So my axis of symmetry is at x equals 2. Step 3 says plug that x value into your function. This will find your y value. So I'm just going to plug in 2 everywhere I see an x. So I'm going to plug in a 2. So I have 1 times 2 squared minus 4 times 2 minus 5. We're just going to type this into a calculator. Skip. And we're going to just literally type that into a calculator. So I'm going to type in 1 parenthesis 2, square it, take away 4 times 2, and then take away 5. When I hit enter, I get negative 9. So I can say y equals negative 9. Now that I have an x value and a y value, I know what my vertex is. My vertex is written as x comma y. My x value is 2. My y value is negative 9. So I can write this as 2, negative 9. So the vertex of this parabola is 2, negative 9. Okay, let's do some more practice. Determine the vertex algebraically for each of the following quadratic functions. The first thing we're going to do is everywhere we see an x squared, we're going to put a 1 in front. So we need to identify our a and our b values. If you want, I'll take a quick little screenshot of this. That way we can look at it. We want to identify our a and our b values. And if you look, our a value, so ax squared plus bx plus c, our a value is a positive 1, and our b value is a negative 3. So now we substitute into the axis symmetry formula, which is x equals negative b over 2a, and then after substituting, we simplify. So I know it's x equals negative b over 2a, and we said our b value is negative 3, so I have x equals negative 3 over 2 times my a value of 1. What's the negative of a negative 3? 3. And what's 2 times 1? 2. What's 3 divided by 2? 1.5. So my axis of symmetry is at x equals 1.5. Now step 3 says plug that x value into your function. This will find your y value. So we know our function is y equals 1x squared minus 3x plus 2. And I said everywhere I see an x, I'm going to plug in a 1.5. I'm going to plug in that 1.5, and now I'm going to type it into my calculator. So I have 1 parenthesis 1.5 squared minus 3 times 1.5. That 1.5 goes into parentheses. Whenever you substitute, you gotta put it in parentheses. And I add my 2, and I hit enter, and I get negative 0.25. So I get y equals negative 0.25. So my vertex occurs at 1.5, negative 0.25. And that's your final answer. Bingo, bingo, bongo, bingo, bingo, bongo. Okay, now we're going to do number 2. Step 1 says identify your a and your b values. So we're going to identify our a and our b values. If you remember, we have y equals ax squared plus bx plus c. So, and again, the number attached to my x squared is my a value. In this case, I don't see 1, so it's a 1. So I'm going to say a equals 1. And what's b? B is equal to 5. So now I need to substitute that into my axis of symmetry formula. So we know it's x equals negative b over 2a. We know we have x equals negative, our b value is 5, over 2, our a value is 1. So I get x equals negative 5 over 2. What's negative 5 divided by 2? Negative 2.5. So my axis of symmetry occurs at x equals negative 2.5. Part 3 says plug that x value into your function. This will find your y value. So I'm going to plug in that negative 2.5 everywhere I see an x. So we know our equation is 1x squared plus 4x plus 5. And everywhere I see an x, I'm going to plug in a negative 2.5. And I type it in. So I have 1 parenthesis, not 1 log, 1 parenthesis, negative 2.5 squared plus 4 times negative 2.5 plus 5, and I hit enter, and I get 1.25. So I can say y is equal to 1.25. So now when I write my ordered pair, my x value comes first. So I have negative 2.5, comma, 1.25. And that's my vertex. And that's it. If you have any questions, please email myself or Ms. Townsend. Have a great day, kids.